so I'm going to give a high-level overview. I'll try to get some time back and talk about what's going on. So I already gave the intro, basically. Computer vision research, actual Google Photos products, and images. I mean, for photos, which I'll show some results of, I mean, we've talked about it before. We actually had, some of Alex's stuff deployed within a couple of months, right, people's people's photos. So let me just talk about some of the applications where we use deep networks, and I'll go into a little bit. But so Google Image Search, actually, deep networks are part of what we use for ranking, actually, in image search. There's also search by image. And for some of the visually similar images, stuff that you see, actually deep networks are also used for that. And as I said, photo search, so this is basically what got out the door, right? Photo search is really a hard problem, so I'm sure Google here would agree, right? Where basically it's either noisy data from users or not much. So these are some results. This stuff is actually launched and out the door. So, if you upload your photos to Google, you can search for photos of coffee or cake or waterfalls or things like that. The other place where it's used is for auto curation. So there's highlights and stories where actually by understanding what's in the images, you can help people organize their photos. It ends up being a really important thing as, basically more and more people are dumping photos out and there's no time to organize. The other place is just kind of places you may not realize. I guess Howard is there on our team, is Auto Awesome. So in some of these types of things, where actually Google automatically adds enhancements, this is actually based on deep networks understanding what's in the photo. So I think this one might be like love or couple or wedding or things like that. Here it might actually be Christmas tree or some other work which is some non-deep work, we're recognizing cat faces or figuring out where to put a photo bomb with David Hasselhoff. And there's a lot of other teams at Google, right? We're just one of the teams. It's used in YouTube, Street View, so driving cars, advertising. A lot of places are using image analysis using deep networks. So I should also say I stole most of these slides from Drago on the team as he gave an earlier talk. And some good slides. So basically, for our team, it's really about extracting knowledge. Right? The sub-team is called the Image Understanding Team, so it's really about kind of understanding and extracting knowledge from the images. And just to go through something that seems sometimes a little bit outside of what the current ImageNet labels look like, is it's not just simple objects that we can get out, right? Some of these kind of scene levels things, like kiss, like you might see, or laughter or happiness. It's sometimes really surprising needing some abstract concepts. It seems like there actually is some visual signal which the networks can pick up on and generate. So now we have, basically everything is going through the deep hammer. I mean, just like the community here internally at Google, right, deep learning, right, for many projects, as well as for computer vision, is really just taking over, right? Just because it really works well for anything that we throw at it. Here's some more personal photos, annotation examples. I don't know, just saw the search, but if you throw in, these are our internal networks, not ImageNet, trained on our own data. So for an image like this, you might see things like things that people really care about for a personal photos type application, where you see a Christmas tree or Christmas decorations or play or meal or crowd. Here's some other ones which came from Drago, from some things internally. You might see things like reflection. It's hard to read, or transport, or even doll or Barbie or clock tower. Some things which seem kind of surprising versus a lot of the nuts and bolts things which we're doing here. Bird, man, bride, ceremony, wedding, tableware, plate, right? All things that are pretty impressive. Here you see rafting, recreation, rapids, water sports, boating. All kinds of interesting labels which our internal networks can pull out. So just some, to have a few numbers, right? Where ImageNet is on the order of like 1 million training examples. The types of things we're doing internally are look at like hundreds of millions of training examples, going more to tens of thousands of labels. And I think we see a lot of the ground truth issues, like Rosenberg brought up. Noisy training data. Basically, when you're going to so many training examples, you really can't have everything being curated, and some noise becomes a problem. Also, incomplete training data. Drago had this good example. We know that this is an Airedale Terrier, but we don't know that it has these other types of pet or cute, and we don't want the network to learn not to output those, right, not to have a negative signal. The noisy data, you know, if we, obviously since we're Google, we're mining a lot of data from the web. If we have a label like tortoise, we're going to start to see tortoise sunglasses coming in and just random noise. So, and obviously it's more than just, you know, like the detection challenge, right? It's more than just classifying entire images. A lot of stuff we've shown so far is really about classifying entire images, actually really localizing and understanding the images. And I'll just go through, we can take a look at these are older results, but the more recent results are even better in the ImageNet challenge. And I just want to also go that, you know, it's also for things that we're doing, it's been you know, beyond classification or detection. Embeddings really seem to work and are very useful for a lot of tasks, like similar images, or even for nearest neighbor type classification. There's a paper in CVPR 2014, this is past one about this. And I think Baidu has shown some results like this, but we've really been impressed by these kind of results. Where here, you know, this is a query image, and these are just basically nearest neighbors in the embedding space, right? And there's a lot of visual similarity and a lot of semantics. Here's some more examples. And even more, you know, it's really impressive what the networks can do in these embedding spaces in relatively low dimensions. So the quick takeaway, what's been working, I also agree, you know, Lumiere, ImageNet's been great, right? It's really pushed the field forward. We wouldn't be, I think, where we are today if it didn't exist. You know, we do see more data for our stuff. I mean, I know that Christian said we could have less data, but actually if we have even more data, you know, we do a little bit better, bigger, deeper networks. What basically needs work still is I still feel like we have a big problem with these black box aspects of things for the networks. Again, focusing on networks, I think we really do have an issue with training data efficiency, right? Some of the speakers talked about where, you know, if you have enough data covering all poses and other things, you can get the network to learn things, but otherwise it can't. There's also efficient means of collecting more training data. Like for us, we really want to go to, you know, 1 million classes or things like that. Getting clean and getting ways to deal with noisy training data is important. So a bunch of the teams, a bunch of the folks are here today, if you see them around. Also, we're hiring, so I'll put in that little pitch. I'm Chuck at google.com, so you can just email me if you're interested. There's a lot of cool stuff going on. And